I'm Helen Pickett, work for Severn Trent in the Asset Intelligence and Innovation team, basically research and development. So today I just want to talk to you a little bit about what we've seen using our BactoSenses at our water treatment works. I'm going to put it a little bit into context with you. We've seen a lot of things. It's 15 minutes. We can't share everything with you in that time, but just to give you a flavour of where we are and where we're going. So Severn Trent is a water and sewage provider in the UK. This is us here in the centre of the country. We have 4.4 million connections, which is 8.1 million people that we provide water and wastewater services to. And our price per cup of water is 1 pence for 30 mugs of water. So we're very competitive in that respect. We own and operate 17 surface water treatment works and several hundred groundwater treatment works to provide our customers with the good quality drinking water. So we produce this water to the EU standards. There's a few stats there, but the thing that we are most interested in for Severn Trent at the moment, or one of the things most interested in, is about coliforms, where we have a standard of 0 per 100 mils. We're interested because it's a potential fecal indicator, and we have to achieve this standard 100% of the time at the water treatment works and 95% of the time at the distribution service reservoirs. So this is our limit after disinfection. So everybody has this limit, but why is there particularly important for us to be focused on this as a challenge? So it's a matter of public record that Severn Trent hasn't been a great performer in terms of bacteriological compliance. So we are funded in 5-year periods known as AMPs. And in AMP 5, which finished in 2014, at the end of that AMP, 13 of our surface water treatment works had failed on coliforms. We have incentivised performance measures set by the regulator to help drive improvements in water quality. And the regulator asks the water company to focus on challenge areas. So for us, coliform compliance. So in the following 5-year period, we had our targets. And at the end of that, we were only just meeting what we were asked to achieve. In this current AMP period, this is the end of the first AMP period, the incentive has changed again, and this becomes very important because we are now under something called the Compliance Risk Index. So this evaluates the risk associated with a failure of the water quality parameter. There's a multiplier involved dependent on how many people could be impacted. And there is an element which takes into account how, as a water company, we have responded to that issue. We have, as we fail, we get points against us. So we have an allowance of 2 points, and then for every point after that, there's a fine which comes in at about £1.9 million. So that's quite a challenge for us to meet as a water company, because that money comes directly from our operating costs. So what's been the challenges for us to meet all of these targets? So first off, raw water quality, it's very variable. So particularly when we extract from a river rather than a reservoir. Sampling, we've already touched on sampling, but how frequent? Once a day. How the time of the day? Usually during working hours. How representative is that sample of your output? There's some stats here that are calculated as a percentage of our output of the megalitres per day, smallest works and largest works. It's a very tiny snapshot. And in terms of times of seconds, it just puts that into context for us. And then within the analysis element, there's the accuracy, etc., the time to result. And a thing which is quite important, it is the visibility of the data to the operations team. So they don't get to see that data until quite a long time after. the result has been generated. So we said, well, okay, what the methods we've got now do not meet the 24/7 nature of our business. They don't support good root cause analysis when there's a problem, and we can't prevent risk, and we can't measure the benefit of a mitigation when which would be put into place in response to a problem. So we're always reactive, we're on the back foot, and we really need to improve. So, long story short, we ended up finding BactoSense, and it looked like a very good technology that we could use. The philosophy behind what we wanted from an on-site measuring technology was that it has to be, one, deployable on-site. This is a picture of a very nice environment for the BactoSense, but some of our environments are much less nice. They have to be online. They have to be easy and robust. We have to be able to measure pre-disinfection and post-disinfection, where we can be using at times up to 3.5 milligrams per litre of chlorine at the the front end of disinfection. The results have to be easily visible to operation and generated quite quickly. And we also want something which is flexible so that we can do investigative work. So the BactoSense ticked quite a lot of those points for us. So whilst our challenge is around coliforms, we've not been able to find anything online that works for potable water for coliform detection. So we've been running with the BactoSense at different sites for anything up to 15 months. And the things that I'm just going to talk through quite quickly and to give you an idea of the things that we've started to look at are coliforms disinfection, temperature, retention time, and visibility of data. So one of the things we were hoping to do is to see whether the TCC would be able to be a predictor for us of coliforms going into the contact tank. So this is from one of our sites. It's post-granular activated carbon, which for our water treatment works is the final phase of treatment prior to disinfection. So the water is very clean, less than 0.01 turbidity. Organics have been removed, pesticides have been removed, and basically we're left with fine particulates, colloids, and bacteria. So when you look at this, you can see that there are areas where you think maybe the TCC could be an indicator for challenges of coliforms, but in other areas we don't see this. And the Pearson correlation says it's only a 0.2 correlation, which means only 4% of this data set can be accounted for. This hypothesis can be accounted for by these two combinations of data. So that was one area where we haven't really yet managed to move forwards. I'm going to go through all of the things and then we'll just talk a little bit afterwards about how things may fit together. So the efficiency of disinfection is an area which is also very important to us. So we measure before the contact tank and we measure after the contact tank. Before the contact tank tells us whether or not our process is working well or whether there's been an unexpected challenge from the raw water. And post-disinfection tells us whether our contact tank is working well. So in this example, most of these examples have come from Site A, where we've done most of our work. We can see that over this two-week period, we only had one contact tank in operation. We can see that there are times when the TCC coming out of the contact tank don't really match what's going into the contact tank. And there are other times when it does. So this kind of information gives us the insight which says that here in this kind of area where the TCC coming out of the contact tank is quite stable, that this contact tank is being very efficient and working well. But at other times, we are seeing still a good removal, but not as good as this. So we might want to look at this area to try and understand what the problem is here. And then again here, where the TCC is decreasing coming out of the contact tanks, but staying quite stable coming into the contact tank, we may want to see what's different here and how can we use this data. So is there anything that we need to understand here so we understand our works better? Is there anything happening here which is preventing disinfection working so efficiently? Is there anything happening here which has caused our disinfection process to improve? So one of the other areas that we've been finding quite a lot of interest to evaluate and understand is about the influence of temperature. And temperature, so this is the monthly average for 2020 at Site A. And this is temperature. This is TCC from the post-disinfection. And again, TCC post-disinfection, but this is the TCC loading going into the contact tank post-GAC. And what we can see here is with the lower temperatures, around about 10 degrees, we see an increase in the total cell counts coming out of the contact tank. And as the temperature increases, we see a very sharp decline. And on this scale, it's not so easy to see, but these results here are under 500 TCC per mil. And then as the temperature starts to decline again, we start to see an increase in this TCC. And this increase and this variation has been seen moving into this year as well. But the interesting thing also is that as the temperature here increases over the summer, our loading going into the contact tank is also increasing. So this demonstrates very clearly how much more efficient our disinfection process is in the summer months, May, June, July, August, than in the winter months. And this is around about the influence of temperature on the dissociation of chlorine in water, and in the colder temperatures, less than 10 degrees, you get less dissociation to hypochlorous acid, which is the active part of the disinfection. We're also being able to visualize for the first time the importance of time in the CT calculation. So the CT calculation is about the amount of chlorine you add per litre of water treated, and the length of time which you react those two components, chlorine and water, together. And the result is in milligrams of chlorine per litre per minute. So at this site, this is 2019 moving into 2020. It's Site A again. And we can see here, this is the TCC coming out of the disinfection tank, the contact tank. And this is the retention time, how long the water is in contact with the chlorine, how long it's in contact with the chlorine. This work was done in the winter, so we're talking November, December, January, February. So this is the time when our disinfection is less effective. And we can see here the cell counts were very high, over to 200 to 250,000 TCC per mil. Here we put in the second contact tank, which had been out for renovation. We doubled the retention time and our cell counts dropped to 10,000. A little bit of a peak here going up because this is when the colder weather hit us in this particular year. So by doubling your contact time, you reduce your cell counts by 2 or 3, 4 orders of magnitude. So this is now sort of operationally, we think, well, okay, now we can understand and we can measure what we do. So we can choose now, do we reduce the number of contact tanks we use in the summer months? Can we increase our flow and reduce the retention time through 2 contact tanks? Do we reduce the amount of chlorine that we're using and save money on chemicals? And we can make the changes, and we can immediately measure the response of our process to that change and measure the potential risk using the BactoSense of that change. In this site here, which is site B, this work is from the summer months, July and August, when our disinfection is at its best. So these are 2 contact tanks run in parallel. They receive the same water. This contact tank has very high cells, 20 to 80,000 cells. Its mean residence time, the time it spends in the tank, is 9 minutes. And here, at an extra 75% retention time, our cell counts are well under 1,000. This is a typical fingerprint for here, and you can see the cloud of cells. This is the typical fingerprint for here, and you can see it's very much clearer. So this then helps us understand and to visualize differences between tanks and what we can do to balance the flow or improve the performance in one tank compared to the other. So if we have a failure site currently, we would think perhaps this tank is likely to be the bigger contributor to the failure than this tank because it has more cells. Now, one of the things that was really important to us is about how do we present this data to the operations team. So all the data I've taken and shown you so far is the data which has been downloaded from the BactoSense and imported into folders or on our servers. And that's great for us to do the manipulations, but it's not really very handy for the control room who respond to alarms and need to see the graphs. So I've pulled out these graphs from just one of our sites. So different sites, but you can see here, it's the kind of thing that you can get on the screen. So this is 1 whole year's worth of data before disinfection, after disinfection. We're still optimizing our scales. This flat line here is actually a failure in getting flow to the BactoSense, but these ones is where we've hit the upper limit for the SCADA limit, the SCADA, which takes the data from the BactoSense to the operations arena. But on a more day-to-day basis, so this is just over a month, we can get much more granularity of data. So we'll be taking this information and working with our operational parameters, such as temperature, retention time, seasonal variation, river flow, stabilities, all sorts of things, and working with the operations team to start setting limits on cell counts going into the contact tank and cell counts coming out of the contact tank. So just to summarize, this is really for us, it's very exciting because it's the very first time we've had visibility and real-time monitoring for bacteria. It doesn't tell us what the type of bacteria are, but it shows us a number in real time. And for the data people behind all of this who will be looking to make improvements, we can start looking at the fingerprints, drawing the information out of there and seeing what we can do with that to improve the benefits of using flow cytometry in the water industry, particularly in Severn Trent, but UK and worldwide. I've only shown a very small fraction of the work that we've done, but what we've learned and understand is that actually for every difference that we see, it's always a variety of factors which are influencing those changes. but at any one time, there may be one factor which has a greater influence than the others. So one example of that is temperature. So in the summer, there may be things going on in your processes or the raw water, but the disinfection still works very well because the temperatures are higher and you have more efficient disinfection process. So our vision is to remove from the reactive place where we are now, have a sample, wait for the result, find we've got a failure, not be able to do a root cause analysis properly, to being proactive where we can say, okay, our total sales are going up. Let's look at all of these other parameters. Now we need to do something. What do we need to do? To becoming predictive, where we start monitoring all the right parameters in the right places, and the right place may be much further upstream in a river or deeper or further away from the draw if in a reservoir, so that we can pull all those together and say we have this combination of circumstances. This means your works could be at risk. So that's the end of my presentation. I hope I've not gone too fast or too long. Thank you very much for listening. This is bNovate, Segrist and Severn Trent winning an award in the UK. And this is Stefan, who has helped us through thick and thin, through the very beginning of our adventure with BactoSense, which has been very early on in its development into the water industry. So although I don't think Stefan is on the call today, I would like to record my special thanks to Stefan for all his support. Thank you very much.